Ladies and gentlemen, good afternoon. Good afternoon. Welcome back for those of you who was here this morning. Let me know, who was here this morning? One person. The jury were here, 5 people and one person. Fantastic. So most of you may not know what on earth this is. This is the JEC World 2022 Startup Booster Competition, all about fresh ideas, all about innovation, big ideas within the composite industry, the leading composite competition in terms of innovation, in terms of startups bringing forward their ideas, showcasing those ideas, finding solutions to deep challenges, constant challenges that the industry is facing, and showcasing them right here during this platform. This morning we listened to 10 fantastic big ideas, 10 finalists of the competition. Right now, we're about to hear another 10 of this competition, in fact, in the category of process manufacturing and equipment. So if we go back 5 years, launched in 2017, Startup Booster has already helped, nurtured, and kind of put them on their way, more than 600 innovative projects. And this year, as I say, is the 5th year of the Startup Booster competition. So it's a year to celebrate and a year to kind of, as I say, celebrate and enjoy the ideas that we're about to hear very, very shortly indeed. Again, this edition attracted more than 150 applications, 150 different big ideas from more than 30 countries. So it really does prove the credibility and also the outstanding performance and the outcomes of what this competition actually has as well. This is a competition. Naturally, it would not be possible at all. It would not be possible at all without support, without our friends, without support from our partners, support from our sponsors. So thank you so much to Airbus and Mercedes-Benz for being the main innovation partners, and also equally Magna International as our individual innovation partner as well. So thank you so much to those organizations and companies as well. Among all our applications, JEC Group, together with our partners, sat down, had a look at all these more than 150 applications, all these different countries. I don't know how they did it. It must have taken a long time indeed. It was probably a long process indeed, really, to find 20 outstanding finalists. We've heard 10 already this morning. We're about to hear the next 10 right now. And then tomorrow afternoon, I believe at 2:50 on this very stage, we will hear, out of those 20, who the 3 main winners are. They're not first, second, and third. It will be 3 equal winners. They will walk away winners of this year's competition, but also 1 other winner as well, the best sustainable concept as well. That will be we'll find out who walks away winner of that. So 4 all in all. A competition would not be complete without a jury or people who will decide the fates of these startups. You will have naturally your best ideas. You will judge for yourself, maybe share that on social media, who you feel maybe who should walk away winners of this competition. But we also naturally have 5 distinguished jury members, experts within the composite industry as well. Let me just introduce to you exactly who they are. Well, I don't actually need to introduce to you. You can see right on the screen behind me exactly who they are. They are our 5 distinguished jury members, and they will decide the fate of this competition and who walks away a winner. Now, the rules, very simple indeed. 5 minutes. 5 minutes to share. Could you do it? 5 minutes, short and sweet. Share your big idea to get people to have a conversation with you, persuade them, encourage them to have that conversation and take that further. That's exactly what each of the 10 startups will do on this stage on my left over at the podium there, up to 5 minutes. And then 3 minutes of questions from our jury members, digging a little bit deeper underneath the surface of the bonnet, let's say, of the startup to really feel what how that startup ticks as well. I think it's time to reveal the first startup. I'm intrigued as much as you are really to see and hear what the next 10 set of startups have to offer. So our very first startup, first of all, and as again, a completely international set of startups. We heard from startups all around the world, and we're going to do it all again right now. So this is a startup, in fact, from Switzerland. The name is Antefil Composite, and we're actually going to have two people who will be pitching the idea. So co-founder and operational lead Nicole AEGERTER, together with co-founder and executive lead Christoph SCHNEEBERGER. Put your hands together for our first two finalists.
Hi everyone, I'm Nicole and this is Christoph, and we are happy to introduce you to Antefil Composite Tech. Some of you might be familiar with Henri Darcy's law on flow through porous media. In fact, his theory explains what we've been struggling with over centuries: how to combine high viscosity fluids with porous textiles. But let's have a look at two specific examples. For automotive applications, large series production is today achieved by rapid stem-forming organosheets. However, these organosheets are today produced by impregnating dry textiles with high melt viscosity thermoplastics at high pressure and low line speeds. This makes these preform materials expensive and limits their use in such a cost-sensitive market. The other example are large composite structures like wind turbine blades that are today produced using vacuum-assisted resin infusion. Because of the curing of these resins, the production is slow and expensive. And because these resins cannot be recycled, we are producing kilotons of composite waste each year. At Antefil, we have the solution. Our technology relies on hybrid fibers, glass fibers that are individually coated with a precise amount of thermoplastic polymers on them. Textiles made from these fibers turn into lightweight structures almost instantaneously, simply by applying heat and a little pressure. We have successfully demonstrated the production of sample-sized textiles with our lab-scale fiber spinning prototype. These textiles can be consolidated into high-quality laminates with low-pressure consolidation, like vacuum bagging, because we combine reinforcement and matrix in every fiber. This ultimately enables the use of thermoplastic composites for large structures, but also parts with high lot sizes. And now to Christoph.
Thank you, Nicole. So by entirely circumventing time-consuming impregnation and enabling a full fiber wet-out, Antefil's hybrid fibers reduce the cycle time in part production while improving the material quality. And because we enable the use of thermoplastics, we offer our customers alternative joining processes such as welding. We don't have to work with hazardous thermosetting and curing reactions, and enable recyclability at the end of the product life cycle. While various applications are conceivable for this preform product, we have secured interest in niche applications, the construction markets, and in automotive, and are running pilot projects with prospective customers there. The experience gained with these pilots will allow us to then also enter larger markets like pressure vessels for hydrogen mobility, the aerospace sector, and wind power. We will strategically position Antefil on the material side as a producer of hybrid fiber textiles. We envision an asset-light production model for which we will collaborate with established fiberglass producers and textile companies. We will incorporate our developed coating stage into their spinning plants, and we've already signed interest from established fiberglass manufacturers and weaving companies for this purpose. So the team behind Antefil is an interdisciplinary team with complementary characters, and we combine over 50 years of experience in the composite sector. The core team is made up by Nicole, Paolo, Thomas, and myself. And as an ETH Zurich spin-off based in Switzerland, we have spearheaded the development of this technology at an academic level. We've also been able to attract highly trained staff and top student interns for our technological and market efforts. We are on a mission to advance the standard in composites production. And to scale our fiber production capacity, we are now offering an equity investment opportunity until the middle of this year in the size of $2 million US. And if you are rather one of our prospective customers and you're interested to have first grab at this technology, stop by our booth, come talk to us. We have some complimentary chocolates. And let's discuss an exclusive pilot project offering so you can test yourself if this material suits your application and how we can help you advance the efficiency of your process without needing impregnation in the entire value chain. So we say, merci, monsieur Darcy. Now let's look together ahead into the future.
There we have it, hands together for Antefil Composite Tech. And I know what you're thinking, don't just go over there for the chocolates.
No, do.
Or you can if you want to. Right, let's hear from our jury members about what they feel, not just about the chocolates, but about what they've just heard.
Yeah, could you elaborate a bit on the maturity of your product? So do you have a product? What is the maturity? Could you also say why have you chosen glass and not carbon fiber?
Certainly. So the second question is fairly easy to answer. We require access to the single filaments for coating, which we're not able to do with carbon fibers due to how they are produced as a precursor spinning process, and then they are carbonized in bundled tows. We cannot do this with our coating application. We have, because the coating would carbonize as well. So that's why we've chosen glass fiber, because there we can access the single filaments while they are formed. So it's an inline process. The maturity of this is that we have a running prototype at ETH Zurich, still at university, so very low scale. We produce samples. We have the pilots which are running our sample tests for characterization, and we are establishing a pilot plant which is upscaled with a capacity of 50 to 70 tons per year, which we plan to commission at the end of this year, start of next year.
And what is your targeted product? I assume that this has a cost. What is the value for that cost, and would that be, let's say, accepted by the market?
It depends on the application and on the market, so especially depending on the choice of the matrix polymer. Of course, that's an inherent part of the cost that needs to be looked at, and we offer tailored microstructuring of the coating. So for specific applications, especially low pressure consolidation, like in vacuum bagging, that's an important step. Which is also highly cost sensitive. We've run cost calculations for this. The pricing is not fixed yet, but we can say that in comparison to established hybrid thermoplastic feedstock material, which is not drapable, ours is, we can roughly halve the costs.
Next question. You say it is drapable. Is it not difficult to preform and
It behaves like a dry textile, but you can weld it, you can preform it using heat. We have a demonstrator at the booth.
Any more questions? No, everybody's happy, looking happy. Well, not actually looking happy, but poker-faced looking happy. There is a question, quickly.
Yeah, quick. Sustainable materials, do you have solutions for that?
That depends what you describe as a sustainable material, I guess.
Recycling thermoplastics or something.
For the time being, no, but in theory we can also use recycled thermoplastics. Our process is completely not relying on those kind of things. So it all depends essentially on the mechanical properties that you want to achieve in the end.
Okay, ladies and gentlemen, hands together for Antefil Composite Tech. Thank you so much, Nicole and Christoph. So there we are, setting the tone of this second category, our first of 10 finalists this afternoon. What happens now? Our jury members, they look down at their evaluation score sheets, and they're not giving much away. Again, if we can get a shot of all our jury members right now, if we can get a shot of them, poker-faced as usual, never really knowing what's going through their minds. We haven't got a shot of them. That's fine, right? Let's continue. We move on now to our next finalist. Our next finalist from Switzerland. Already we move over to Germany, and this is ANYBRID. ANYBRID, please welcome to the stage the co-founder of ANYBRID, Mr. Michael STEGELMANN.
Hello, my name is Michael and I'm the co-founder of ANYBRID. And I want to start with a childhood memory. Do you remember those telephones? They revolutionized the way of communication. And what was the biggest thing that happened to the telephone itself? We made it mobile, creating a whole new level of flexibility and productivity in our everyday life. And well, let's keep that in mind for a second and transfer it to machining technologies. For example, injection molding. Well, injection molding, the most common used manufacturing process in the plastics industry. I'm not saying it is outdated somehow, I'm just saying it is, well, stationary. And again, what could be the next thing that happens to the injection molding technology? We can make it mobile. We from ANYBRID have succeeded in creating the world's first mobile injection molding machine. And with that, we are leading to whole new flexibility and productivity in plastics processing. And we call this machine Robin. Robin consists of a lightweight C-frame and is characterized by a weight of only 140 kilograms. Like this, it can be mounted on classical industrial robotics. Besides that, it's characterized by the big outreach capacity on the inside of the C. So what can we do now with this machine? We can add it to other manufacturing processes like metal processing, thermoforming, or composites processing, or even wood or foamed material can be overmolded with our technology. But just think about the technologies, how we can overmold profiles in line. Because today, profiles and injection molded elements are completely separated when it comes to the production of them. There's always additional joining necessary, and the geometry for such hybrid profiles in the end is limited. We use this in cooperation with our first big customer, REHAU, one of the biggest plastics manufacturers in Germany, to test it online during an extrusion. We are just flying by the profile, overmolding it with a functional element out of the same material. And think about the market. There are over 5,000 profile extrusion lines that are sold in Europe every year, creating a turnover of over 2 billion euro. And this is just, for us, the start, because we developed, with Robin in the center, an injection molding machine that can be directly integrated in a profile extrusion line, making it possible to overmold it directly in line. We are expecting to sell over 50 machines in the next 5 years. And this is just the possibility to overmold in line. When it comes to offline functionalization, we are aiming for another market, the market of window frames. There are over 15 million windows that are produced and sold every year just in Germany and France, creating a turnover of over 1.5 billion euro. And what is the most challenging part about windows is the assembly of them. And that's where we come in the game, because we created, with our Robin system, a joining concept to join the window frames directly with a higher speed, reducing the need for labor in the traditional ways. We are expecting, with those and other applications, a turnover of up to 30 million euro in the next years. And we're planning to scale it on other areas in the automotive or aviation industry, or with other materials, overmolding metal or wood material. And we are already in discussion with a few manufacturers when it comes to joining technologies, joining C-frames. Last but not least, I want to introduce you to the team. The team consisting of the one who keeps everything in his eyes, the mastermind, the networker, and the one who can just do everything. Altogether, we have experience of 45 years in engineering and have been multiply awarded in the last years. With that, I want to finish my presentation. I want to invite you to think with me the next steps using our robotized injection molding system. Thanks for your time, and I'm looking forward to meet you at our booth in the Startup Village. Thank you.
Ladies and gentlemen, hands together for ANYBRID. Okay, let's hear from our jury members about what they felt about what they've just heard.
Yeah, so you're bringing the process to a product. The products that you've shown seem quite simple, I mean, or are cheap. Does it have a business case to really have such a flexibility?
The flexibility is one chance to have the option when you think about a profile that is extruded, where you can just vary the distance of the functional elements that are overmolded onto the profile. This can be an example, or if you think of big components that are thermoformed in a way, and you need different functional elements on different positions, but sometimes you need some stiffness on the one corner and you don't need it on the other corner. So you have a lot of flexibility when it comes to product design. And always when you have these big injection molds, the molds is always limited by the design, that you don't have any flexibility. So people are thinking in using additive technologies to additively print elements on them. But then we come in the game and say, well, you can just use small molds and just overmold it locally where you need it.
How do you manage the flexibility of the designs? Yeah? So you need many molds. How do you do that?
Yeah, well, it's a base mold system, and so you can just switch the insert, which is the cavity of the mold, with a quick switch system. You know it from milling, drilling machines, where you can just switch the mold online. So we have actually a mold cassette garage, so to say, where we can just switch the molds quickly.
Okay, thanks.
Well, what is the biggest size of a tool you have ever done with your machine?
Well, it's quite small. It's 150 millimeters times 150 millimeters in area, project area.
I think we've got about 20 seconds on the clock, quickly.
I'm going to ask a short question. Let's say, how do you do automation? Because you also have the extrusion line running off the profile. I see the hardware, but you also need, let's say, to make sure that it syncs. How do you do that?
Well, on the automatization area, we are working together with partners, with classic automatization companies, manufacturing companies, machining companies, who are delivering us the right equipment for the right application. If it is a linear system, if it's a robotic system, it just depends. So, yeah.
Ladies and gentlemen, hands together for ANYBRID. Well done.
Thank you.
Now we have it already. We've listened to our first two finalists of this 10 set of finalists for the for JEC World 2022 Startup Booster Competition. Again, if you've just joined us, remember this is the startup competition for the composite industry, running for 5 years already, and it's going to run for another, well, I'm sure for another 5, even more into the future as well. And remember, we'll be celebrating this a little bit later after this competition at the Startup Booster Village for something to drink, some chat, some conversation. We might even, you can bring over those complimentary chocolates as well. We haven't got any, but you can bring your own, and we can have some conversations and networking over there as well. We move on to our third startup right now on stage for this competition. This is a startup from the USA, right the way from the USA, arrived a few days ago, Atomic 6. And Atomic 6 President and CEO will be speaking right now. Please put your hands together for Mr. Trevor Smith.
All of us here have one thing in common at JEC World: to meet like-minded individuals pushing composites for a more sustainable future by reducing costs and improving performance, ultimately doing more with less. Atomic 6 has solved a problem that our industry has had for the past half-century. We're manufacturing the world's highest performing composite parts for the most critical, demanding, and harsh environments. We're backed by IronGate, an aerospace and defense venture capital firm, one of 20 out of 3,000 annually chosen to be accelerated by Starburst, the world's first global accelerator for aerospace and defense. Here's a quick picture of what Atomic 6 is all about.
They said it couldn't happen. Until somebody did it. This panel changed everything. Historically speaking, industry's best has achieved 80% of the theoretical limit for tensile modulus. This panel, 98%, 2% away from perfection. We're applying our technology in 4 major verticals: space, aerospace, hypersonics, and ballistics. Space, we've made a chassis for a Mars rover prototype that's lighter than aluminum and stronger than steel. Aerospace, we've made a battery enclosure for hybrid electric aircraft. Hypersonics, we're developing a carbon phenolic panel to withstand speeds of Mach 5. That's 3,800 miles an hour. Ballistics. Our first attempt, we stopped a 9mm full metal jacket, beating the military standard for weight and thickness. The products that we're making in each of these verticals have interstate, international, and interstellar implications. At Atomic 6, we invite impossibility because we know impossible is the first step toward an entire generation's dreams coming true.
I'm sure you're all aware that prepregs are the benchmark material for high performance. You also know the problem with prepregs. They're expensive, have excessive resin waste, limited recyclability, stored in a freezer, and typically require long curing cycles. The benefits are that prepregs have well-established properties that have been certified for many programs and have a high level of performance. We're disrupting aerospace, providing performance previously thought impossible, 120 times faster manufacturing at a fraction of the cost. Our proprietary mold design allows for all fiber and infusible resin types. I have 2 chassis here from the same mold. The first is an IM7 woven carbon fiber and high-performance thermoset, while the other utilizes recycled chopped carbon fiber and a recyclable thermoplastic resin system. To meet growing demand for sustainable aircraft, we must utilize composites while drastically increasing production capability. The Atomic 6 process is purpose-built for opportunities just like that. Our goals are big, 4 trillion big, and it takes big equipment to meet those goals. That's a picture of Mars, the next opportunity for humankind, next to our largest autoclave, big enough to fit payload fairings for rockets bound to the red planet. Over the next 2 years, the world will launch more satellites than in all human history combined. Space Force has funded a $750,000 project for us to develop higher performing support structures for solar arrays like the ones on the International Space Station. Once proven, this technology could help bring 5G Wi-Fi to every single corner of planet Earth through projects like SpaceX's Starlink and Amazon's Project Kuiper. The next generation of fighter jets won't have pilots in the cockpit. The Air Force Research Lab has funded a $750K project for us to improve critical structures on its unmanned combat aerial vehicle. With a $150K grant from the Air Force, we're developing the next generation of high-heat composites to withstand 5 times the speed of sound. One of our goals at Atomic 6 is to help save lives in dangerous environments. Stopping a 9mm full metal jacket, we beat the military standard for both weight and thickness requirements on our first try. If you're watching online, let's have a conversation on LinkedIn. For those of you in the room, we're here to speak to investors regarding our upcoming Series A with experience in advanced manufacturing, space, or aerospace. We also want to meet brilliant engineers, and I'm out of time.
And you're out of time. Ladies and gentlemen, hands together for Atomic 6. Right, our jury members, let's hear from them about what they've just heard.
Thanks, Trevor, for the presentation. Maybe one question: what is your secret ingredient? What is the secret sauce of Atomic 6? Not very clear in the video, right?
Sure, yeah. You and every defense prime in the country wants to hear that. So our special sauce is a mold technology. It's the way that we manipulate fiber, resin, and void inside a high-pressure environment like an autoclave. So it's the mold design that's the special sauce.
And second question, what is the sustainable ingredient in all that? Is there a specific thing in the mold?
Sure, yeah, so the beautiful thing about our process, it's agnostic to the raw inputs. So we can work with thermoplastics and thermosets. So if you have a customer who wants a recyclable, sustainable end product, we use sustainable products to meet that. And the benefit is our process pulls out more performance than anyone else in the world. So you can use lesser performing materials in a demanding environment. That's the idea.
Thank you.
Other questions from our jury members? Happy? I hope that's a yes. Again, poker face. They never know what's going on in those minds of our jury members. Ladies and gentlemen, please, hands together for Atomic 6. So there we have it, from the USA, Atomic 6. We move on now and we go from the US back to Europe, over to Germany. And this is a startup very simply known as Carbon Drive. And the CEO of Carbon Drive is about to share his pitch with you right now. Please welcome to the stage, Martin KLIMACH.
Thank you, Peter, and hello to you all. I'm Martin KLIMACH of Carbon Drive GmbH from Germany, and we work very hard to lighten up electric drives. My own personal history with composites started actually 25 years ago with my first pair of fiber-reinforced flippers. Their superb performance helped me break world records and become a world champion. And my obsession with what I call the superpowers of carbon fibers, together with my determination to succeed where others have failed, led me to spend my entire research as a PhD and postdoc into unlocking those superpowers for electric drives. To understand why electric drives can so benefit from those powers of carbon fibers, we have to understand the limitations that steel today imposes on electric drives. If you build anything, it will have a weight. If you use steel, it will have a lot of weight, which will need a lot of energy to accelerate. Energy, thanks to physics, always leads to heat, and this heat in your steel parts will lead to thermal deformations. And those are the real killers of electric drives today. Here, the physical properties of carbon fibers can be a real game changer. So my team and I, we focused on the very most advanced electric drive we could find, which are today electric motor spindles. They are the spearhead of electric drives currently, and they are like a Formula One racing car compared to a road car, if you compare steel motor spindles to standard electric drives. And like in the racing industry, the technologies that are today standard in electric drives were first introduced a couple of years earlier in motor spindles. So it stood to reason that if we make a carbon fiber motor spindle that can machine the same speed and precision like a steel spindle, we would not only make a big impact on the machining industry, and which industry doesn't rely on machining, but also in the long run on electric drives in general. So after countless hours of research and meticulous product development, we, in the middle of 2018, had our first all-carbon electric motor spindle. It can machine aluminium up to 4 times faster than a steel spindle with twice its weight. It shows no thermal deformation, and in the milling process saves 40% of energy. The first prototype is actually still running today in our production as our day-to-day spindle. But back then, we had something maybe even more important. We had formed the perfect team. We have Alex, who is our exceptional economical expert. We have Jan, who is a very patient, precision perfectionist, and me, a modest mechanical mastermind. And back then, boosted by our research and confident in our abilities as team, it was time for the project Carbon Drive to be the company Carbon Drive. So where are we today? Today, I stand before you as a founder of a composites company that couldn't be more excited about the future. We have received local, national, and international awards and grants. We have many research cooperations with technology leaders, but most importantly, we are right now building the first 2 models of motor spindles, of all carbon motor spindles, that will go into serious production and will set the new gold standard for energy efficient machining. They are about to produce 10 million euros per year in revenue. So, I have told you everything about our team, about our great technology. I hope I could convey you our vision of the future of electric drives, of energy efficient electric drives. And if you feel you share this vision, if you want to contribute, or if you feel we have maybe other applications that we haven't thought about, please reach out to us. We are very happy to get in contact with you. Thank you.
Ladies and gentlemen, hands together for Carbon Drive. Wonderful. Again, let's go over to our jury members and hear what they feel about what they've just heard.
Yeah, thanks for the interesting update. Spindle drives and the production behind that. Can you give a little bit more insight on how deep your vertical integration in the process is? Are you only designing it, or are you producing it, selling it? How far does it go?
Thank you for the question. Yes, so we have right now a very deep production. That's why our team is so important. So Jan, at the moment, is back at home. He's using our first prototype to build the next spindles. And so we do the fiber winding ourselves, of course, all the calculations beforehand. We do the initial grinding of the raw parts, and then, of course, the motor we buy and the bearings, and then we do the assembly again, and also the in German it's called Inbetriebnahme, so the first runs, the initial runs in the beginning. Yeah, and then it goes to the customer, and he does the tests in his machine to see what his gains will be.
Okay. Second question, more selfishly for the automotive. Electric drives are coming also more and more in the automotive area. Are you working on other applications than just spindles right now, or are you?
Yeah, yes, we definitely had customers from the automotive industry. Yeah, exactly. And yeah, of course, the drives in cars also benefit from a lighter structure. Especially in the shafts, if you can save weight, you directly have more of your power to accelerate your car instead of accelerating your motor.
A little bit of time now for last question, perhaps. No?
Yeah, you mentioned 400% more productivity. Is that something that you were able to prove in practice, or is it an assumption?
Exactly. No, that was something we achieved on our own milling machine. And this is a bit more tricky to explain. So if you machine something, at some point, if you increase the depth of cut, at some point it will start to chatter. And here, the dynamic properties of your materials are very important. So the stiffness and the weight, and also the dampening. And all those factors are much better with carbon fiber than with the steel. So in the whole process, we could machine a 4 times deeper depth of cut at the same feeding speed without chatter than with the steel spindle that was twice as heavy.
Thank you.
Of course, it also helps to have if you have less weight, you can put more weight into motor performance. Yeah.
There we have it. Ladies and gentlemen, hands together for Carbon Drive.
Thank you.
So there we have it. Already 4 of our startup finalists, they've shared their big idea with you. They've shared their big idea with us here in the room in Paris at Jet World 2023. 22. Those of you at home, office, home office, wherever you are, who would you choose already? Perhaps we already have one of the winners from our first 4. Very difficult choice to make. I know it would be difficult for me, probably for you as well. Even more difficult for our jury members here in front of me. And again, I have to say, still not giving anything away. I look at their faces, they look at me, we look at each other. I have no idea what's going on in their minds, poker-faced as usual throughout. Is that a good strategy? I don't know. But we'll find out tomorrow afternoon at 2:50, when we'll find out who the 4 lucky winners are of this Startup Booster competition. On to our 5th finalist. Fifth finalist is actually from Denmark. Denmark, a startup known as Continuum. Please put your hands together for co-founder and CEO of Continuum, Nicolas DERRIEN.
Hi, my name is Nicolas DERRIEN, and I'm the co-founder and CEO of Continuum Holding APS. We're here to announce that industrial composites transformation has finally arrived. Now, I don't need to tell you guys in the room here that today composites cannot be recycled. They go to landfills, they're burned, cement co-processing. You also know that there are many consortiums and research projects right now led by some of the biggest companies and most renowned universities looking to solve this problem, a problem that we have solved. In summary, we've developed the most advanced mechanical composites transformation technology in the world. Our patented circular technology allows us to sustainably turn end-of-life composite materials and manufacturing waste into valuable end products that can be transformed over and over again. Our first 2 36,000-ton, 70 million euro commercial factories are already in planning. Thankfully, it's not just us saying this. UCEA, the leadership of UCEA says the quality and scope of reclaimed materials, its commercial readiness, and its sustainability footprint represents a significant opportunity in the market. We believe that it can form a backbone for a circular composites economy. We also have a collaboration agreement with the National Composites Centre in the UK, and we're honored to be standing here on the deck as well. Now, let me bring you a bit deeper into our technology. It's a 3-stage transformation process. So the feedstocks that we start with today: wind, automotive, aerospace, marine, and construction. In this first stage, we have a multi-step size reduction, sifting, milling, cleaning, and sorting process that allows us to actually reclaim the raw materials. In a second stage, we now have these materials in silos, and it's a bit like baking a cake, if you will. We have these ingredients, and we can mix them according to the specifications of the end product. And then lastly, we have the panel production stage, where we produce our composite panels that, again, are circular and fully recyclable via our process. On this next slide, you see the quality and cleanliness of the raw materials. Now, when technical people, scientists, engineers, etc., look at these, the first question is it really just a mechanical process? Is there no heat, no chemicals? And yes, it's a fully mechanical process. It's 120 machines. It's a dry, autonomous process. And that allows us to start with up to 22.5 meter pieces of wind blade material and then push it through into the end until we get our finished panel products. The product is the Continuum high-performance composite panel. Again, 92% recycled material. It's got really outstanding technical properties, and that's what actually gives us the opportunity to compete against many different products within the building and construction industry. Some of these products, you see drywall, you see facades, bathrooms, even doors, sound barriers, up to competing against virgin fiberglass panels in certain applications. You see a compact secondary substation here. These panels have really outstanding technical and green properties, and we expect to sell in the next 3 to 6 months 15 to 20% of our output. Our first factory is planned together with the Port of Esbjerg. We have 100,000 square meters of waterfront property at the leading offshore wind port in the world. We have agreements in place with all machine suppliers, so in other words, we're ready to go. Now, we see this as a winner-take-all market, and we believe that we have the technology, the product, and the business model to be one of the leaders here. We're planning, in addition to the Esbjerg, a second factory in the UK, and by 2030, we want to establish at least 6 factories in Europe. To close, if you're a feedstock provider, if you're in the media and you want to help us tell our story, or if you feel that we can partner in any meaningful way, please get in touch. We'd love to talk to you. Thank you very much on behalf of all of us, and we look forward to your questions.
Ladies and gentlemen, hands together for Continuum. Actions speak louder than words, although right now we're going to hear the words of our jury members about what they've just heard.
Yeah, thank you very much for this presentation. Very exciting. I think everybody that's contributing to circular economy really deserves an applause. I have a question around track and traceability of raw materials. The wind blades, they can either be epoxy, polyester, maybe different types of glass. How do you ensure, let's say, this track and traceability of raw materials ending up in the panels, and then also complying, let's say, with legislation in the building industry?
Yeah, good question, thank you. So we've tested from old blades to new blades, right? We can handle from the old blades that have balsa wood in them, that have lead, right? All the way through the new blades with carbon fiber, we can handle everything. So we actually use 99% of a blade. We don't use the metals. We separate them, we give them to somebody that can do something sustainable with them, recycle them for us, but everything else we use in these end products. And as far as legislation, part of the next step in terms of the market entry with these panels is that we're working with the Eco-Label Institute in Denmark to be able to certify these as green products so that they can enter the market not just as a building and construction panel, but also a green panel.
Okay. There was here a couple of pages ago somebody on stage that said, well, windmill blades, we should make that with thermoplastic composites. Is your technology also suitable for that?
No, we focus on thermoset, but we're quite confident that between the amount of material that's in the market now and by the time that there's potentially a wide adoption of thermoplastics in blades, that we still have a pretty exciting business opportunity here.
Thank you.
Yeah, thanks for the presentation. Maybe one question. When it comes to the costs of the panels, what kind of premium or upside do you see in the panel costs that you're producing compared to traditional?
Yeah, so we have again, we have a business model that's very attractive. Let's put it that way. And so we're able to, because of our low transformation cost, have a very competitive product in the building industry. Actually, we can sell the panels below competing products' prices. But as you say, is there a green premium for this? And that's what we're answering right now.
Ladies and gentlemen, hands together for Continuum. Thank you so much. Wonderful.
Thank you.
So just again, remember everything you've heard this morning. You heard the 10 startups this morning. Those of you that were here right now, going through another 10 finalists of the Startup Booster competition as well. You're curious, you hear something that makes you curious, or maybe someone in your network would be curious about the idea, about the concept moving forward. Again, remember, all 20 startups finalists are at the Startup Booster Village over at the entrance of Hall 6. And again, pop over there, have a conversation, start a conversation, and see perhaps in the future how you can actually collaborate with our startups and our finalists as well. Moving on to our next startup finalist of the Startup Booster competition right now. Please welcome on stage from Germany, a startup known as Fibroworks. Please welcome on stage Managing Director Lars LINNEMANN.
Good afternoon, ladies and gentlemen. My name is Lars LINNEMANN, CEO at the startup Fibraworks, and a warm welcome from my side. At Fibroworks, our vision is winding the future, and our mission is nothing else than making thermoplastic cross-ply laminates more affordable for mass markets. The realization of winding the future is driven by my colleague Lukas Schulz and me. Lukas is an industrial engineer with extensive knowledge in machinery and automation, and I'm an aerospace engineer with almost 15 years experience in composite processing and materials. And we both do know the challenges of processing composites. We are flanked by 7 shareholders out of the fields of engineering, machinery, patenting, and automation, and are supported by our 4 strong partners, which are regional around us. So all of you know that sustainability is one of our future themes, and you will all agree that lightweight design is a key technology for sustainability. And of course, composites are a cornerstone of lightweight design. But still high costs and complex processing hinders their widespread use over all industries, especially in cost-driven applications. And in terms of sustainability, of course, there are thermoplastic composites which are more often used because of their processability and their recyclability. But they have got also a cost-performance problem. If you want to have high-performance composite parts, you are in the need of high investments, high labor costs, and this leads to a future demand of industrialization of processes which deliver affordable materials. And that's exactly where we step in as Fibraworks. Our aim is to provide an innovative and automated process providing cost-reduced and affordable thermoplastic cross-ply laminates. And we do that with our recently awarded technology, Fibraforce technology. Fibraforce technology is based on a patented winding process. So your D-tapes are wound around a moving mandrel, the orientation is customizable, and the material is afterwards tailored, merged into a flat layup, and then could be locally fixed or fully consolidated. And we at Fibraworks don't want to sell the process and the machine. We want to sell the product. Nothing less than affordable, sustainable organocoils. So what are the main advantages of Fibraforce technology? On the one hand, it's the improved productivity compared to state-of-the-art processes. So we've got a 50% higher output than industrialized state-of-the-art processes, and in the outlook, a later-on production machine with an increased width could even realize 4 times the output than the state-of-the-art processes. So Fibraforce technology provides a continuous processes, providing customizable, multi-axial and multi-layered cross-ply laminates at affordable cost. And this could be a game changer in the composite industry. So what are the market potentials for Fibraforce technology? Thermoplastic materials are more often used over all industries: aerospace, automotive, battery casings, infrastructure, and transportation. And the thermoplastic composite market is growing fast at about 7.5% annually. And the market for organosheets and UD tapes is even growing faster. And to illustrate you the capabilities of Fibraforce technology, providing affordable thermoplastic cross-ply laminates, just listening to the following numbers. Our prototype can deliver 1,000 tons of material a year in a single shift operation, resulting in a sales volume of at least 15 million euros, which is a market share of 1.7% related to 2020. So we want to wind the future, and therefore we need you as a customer with your requirements, and also you as a UD tape supplier. And since we want to produce sustainable organocoils, we are in the need for sustainable materials. On the other hand, we need a phase 2 funding of about 5 million euros to realize our technology and the market entry. And finally, we are looking for partners along the value chain. So thanks a lot for sharing those 5 intensive minutes with me, and I hope you will pass by. We have got 2 booths.
Ladies and gentlemen, hands together for Fibroworks. Okay, over to our jury.
Yeah, thanks. Very, very interesting from the out view and everything. Can you tell us a little bit more about your secret in the process? Because you are so much better than all the others out there.
So the secret behind the process is it's a winding process that's very established and that's very cost effective. And it's very easy to produce with the ultra high productivity that layup. And that makes that process so much better than state-of-the-art processes like stacking materials manually or in discontinuous processes or even with tape placement. The output rates are so much higher, or could be so much higher, that could be the game changer.
Okay. And there are not any limits regarding fiber, materials, and thicknesses of
So, of course, then stiffer the material, then more complex is the winding process. But we have got tests with glass fiber PP, glass fiber PA, and it's also capable of doing carbon fiber PA. It just depends on the radius and the geometry of the winding mandrel we are using.
Okay, I come by.
Thanks.
Okay, a little bit of time on the clock.
From what I've seen, you're winding on something. What is that?
That's the main core of the patent. We are winding on a kind of moving mandrel, which the kind of transportation belts. And we afterwards, after the winding, cut the material, move it into a flat layup, and then merge it together to the cross-ply laminate. That's what we exactly do.
Okay, thanks.
A little bit more time. Last quick question, perhaps? No? Happy? We are happy. Ladies and gentlemen, hands together for Fibroworks. Again, a tough decision right now. What happens in front of me? Again, our jury members, they are looking at their evaluation sheets. They are focused. They're putting down how they feel about what they've heard. If you were a jury member, who would you choose so far? Don't let us know, but I'm sure it'd be quite a difficult decision, or maybe an easy decision. I don't know. Perhaps you already know. Perhaps if you were a jury member, who you would put through as a winner. We move on to our seventh finalist of the Startup Booster competition. We stay in Germany. A startup known as Herone. Please welcome to the stage managing partner of Herone, Mr. Christian GARTHAUS.
Hello, my name is Christian. I'm co-founder of Herone. We are 100% focused on thermoplastic composite profiles. And as you all know, with composites, you can make ultralight profiles. But we think with thermoplastics, you can make them more sustainable as well. And if you look at current technologies that are existing for such profiles, we have either like super high productive processes like pultrusion, for example, or processes where we can integrate additional value into the part, like, for example, autoclave technology. And the demand that we see as Herone is in the upper right for really productive manufacturing of composite profiles where you can integrate additional value directly within the manufacturing process and therewith making those parts more cost efficient than current solutions. What we do as Herone, we are inventing and producing thermoplastic composite profiles where the functions required for using those parts are directly integrated into the parts. So here you can see peak profiles, for example, like a peak tubular structure with, for the pipe, the fitting, for example, is a co-molded peak, so making one robust structure that is ultra-light in the end from all thermoplastics. Our vision is that with that we provide like more sustainable solutions, for example, to make aviation emission-free, like with hydrogen pipes, for example, or storage solutions. Core of what we are doing is the technology. We call it herone technology. It's like a two-step approach. We are always starting from thermoplastic tapes, so pre-impregnated tapes, and are having like a textile process. It's a braiding process for automated deposition of that material, and then making like tailored preforms, so-called like organo tubes for profile structures. In the second process step that we did win the Innovation Award with in 2019, it's like a molding process in which those organo tubes are molded in like a press form process together with the functions to the final parts. Our main asset, of course, is our herone team. So we are a mix of material engineers, like lightweight engineers, and aviation engineers. And with that team, we did scale this technology to like a full production line and achieved aerospace certification last month. So with that, we are now like production ready to get started manufacturing those parts. And this is like a quick impression into what we did build up. And the parts that we are focusing on are like, of course, all like hollow profiles. We kind of categorize them. Like the first one is where we change the geometry, so for more like geometrically complex profiles than for struts and shafts where load introduction or gears are directly co-molded onto the composite part. Then what I already mentioned, pipe structures with integrated fittings or tank solutions. And the fourth category we call like advanced parts where like multiple other functionalities are directly co-molded, like those ribs, stiffeners, or attachment points. So with that said, of course, we are having a solution now and are looking for appropriate applications. And of course, you're welcome to contact us for the challenge you have in mind for such parts. Thank you very much.
Right on time, ladies and gentlemen, hands together for herone. Right on time. Let's hear from our jury members about what they've just heard.
Hi, thanks for the presentation. Maybe first question, how recyclable is your composite, and what is the sustainable part of it that you have?
As I tried to explain, our aim is to make like all thermoplastic composite parts. So the composite structure as well as the functional elements, we call them, is the same matrix material. So in the end, you can like shredder those parts, and we did do like first approaches to then injection mold those parts again into new functional elements, for example. That is like one first track, and we currently are exploring multiple others, for example, using production waste and kind of recycling that to make injection molding compound for those functional elements, for example.
Thanks. And second, you mentioned hydrogen for aviation.
Mm-hmm.
How competitive are you when it comes to leak avoidance and the certification that you can have on these kind of things? Are you already advanced on that?
We definitely are working on that. So we have had multiple projects up front to integrate and investigate different liner materials that are directly co-molded, if you're talking about hydrogen, but that is an ongoing process. I think currently most companies are still investigating, but we are having like metal sheets integrated or other like thermoplastic materials directly integrated into those parts. And if you're talking at like fuel pipes, for example, it is an option to really go with linerless tubes, because the material itself has no porosity really left, and we can just go with like resin-rich inner surfaces, for example, to make them leakage-free.
Thank you.
But would it then be with braided pipes, or is it another technology?
The core of what we do is always braiding, so the preforming we are always braiding and incorporating like additional axial direction tapes. So it's a combination of like a braiding process for the angular fibers and then axial tapes if required for the application.
Lady, that's it. Lady, 3 minutes are up. Ladies and gentlemen, hands together for Herone. Thank you so much. Again, tough decision to make. We've had seven big ideas. Again, who would you choose? Our jury members, they have that task to do, writing down now, giving us their evaluation of what they've just heard. Tomorrow we'll find out exactly who those 4 winners are, 250 right here on this stage. We move forward to our next startup. Next startup is actually from Slovakia. With the name of RVmagnetics. Please welcome to the stage member of the board, Mr. Vladimir MARHEFKA.
Hi, good afternoon, everyone. My name is Vladimir MARHEFKA, and I'm with RVmagnetics, and today I will be presenting the smallest passive sensor in the world, the technology that's able to smartify your composite. Anatomy of a problem. What is the target segment we're addressing today? It's composites. Beside the company is also dedicated to other lines of business, including electric motors, batteries, assembly, and beyond. Problems in the composite industry we see is basically monitoring the integrity of composites and the rising demand for induction welded composites, possibly in contactless and wireless manner. What has been done to address this issue in years or decades before now is the answer always relies on the innovation, science, research and development, and that's basically where we're coming from. Then, of course, together with clients, there's a great deal of testing from the regulatory, also imposing policies that help to adopt the technologies, and last but not least, always sales efforts. So the message we want to convey today is that we're here to help you retrieve the physical data, to mine the physical data, to help you smartify your process, your products, your composite material, or your composite parts. How do we do that? Our sensor is able to respond to that in contactless manner, allows real-time sensing, and helps you to mine the physical quantities of pressure, temperature, displacement or position, if you will, and also structural integrity. This is the sensor. It virtually can become and becomes part of a composite material by being embedded in between the layers during the manufacturing process, and is paired with an interrogation device that helps you extract the data. Our business model is basically divided into 3 main steps. Typically, the first one, getting to know the client and providing them with a feasibility study, which is a quick step that qualifies us to go next to the customization, a lengthy and more cost-intense period where the outcome for the client is prototype. Third and most important step is where we are becoming less of an R&D organization and more of a supplier of the actual microwires or the sensor themselves, and we need to align with the client's go-to-market strategy. What are the benefits and impact of the technology? We are allowing our clients the structural health monitoring on the run, in situ monitoring, non-destructive testing, and if paired with a proper software or artificial intelligence, it's also predictive maintenance. So one way or another, it's modifying your composite and turning it to a self-monitored one. On a sustainability count, where we see ourselves is replacing several sensors, interfacing with one, gathering data, as already mentioned, temperature, pressure, magnetic field, its structural integrity and displacement, help reducing carbon footprint by replacing metallic parts or metallic materials with composite ones. And we as a company don't need to establish global plant network because we're able to basically produce from 1 gram of metallic alloy 100,000 sensors within 10 minutes. Market opportunities, these numbers basically speak for themselves, whether it's smartification count or segments of smart sensors or microsensors, a double-digit growth and stable adoption of composite materials. As for the traction of the company, we have currently 8 clients. 5 of them come from the composite industry, diversified in between automotive, aviation, and medical. 2 filed Horizon projects where we're expecting the answers later this year, and over 100 NDAs signed. Also, the company filed patent earlier last month. The team is based on our CTO, Professor VARGA, who's also academician himself with an impressive track record and who spent 25 years developing the technology. What are the needs of the company today? We're obviously looking for adopters, client integrators, and strategic partners and investors later this year to not only productize fully developed technology, but see through the projects to the very end. Thank you for your attention.
There we have it, RVmagnetics. Thank you so much. Okay, over to our jury members right now.
Yeah, thank you very much for this this presentation. So it's lightweight and smart, so it's a very good, very good combination.
Thank you.
A question regarding longevity. Some plastic parts or composite parts, they remain in service for 10 years, 15, sometimes even 20 years. Do you foresee any problems there with your technology?
Not necessarily on the sensor microwire part that can do the job for longer than a lifetime. Tested and proved. As for the electronics, it's less of a headache. It can be replaced if necessary.
So you can really ensure, let's say, that the sensor is working for over 10 years in the past?
Yes.
Okay. A second part, and I'm not sure whether you've done the calculation. You mentioned, let's say, that it has a low power consumption. Have you ever made, let's say, a quantification of the CO2 emissions of the power consumption for a part?
Not for now, no. We did the power consumption on a single measurement, but not necessarily translated to the CO2 levels.
It would be interesting to see how that compares to the footprint of the material itself or the application in use. Yeah.
It varies from use case to use case. That's why also, if it came to the numbers, we have wide variety of use cases that very much differ. So also the power consumption differs from case to case. So there's not a universal answer right there.
Maybe a last question. I can imagine that you have tested multiple sensors at the same time to see how consistent it is. Can you tell a little bit about that?
Can you elaborate on the question? Sorry.
Well, it's more about the accuracy of the sensor. I can imagine that in a certain part you have, yeah.
Say in the medical space, we went down to accuracy of the temperature per se. It's 0.01 centigrade. That's one of the examples. So yeah, we can go beyond, but many times we came to the requirements to go beyond what's possible today, but there is no other sensor to verify our measurements with. So clients wanted to go one order higher than with a strain gauge. How do you verify that? Well, we don't know. So I'll stick with the temperature answer if that's the easiest one I can provide.
Okay, thank you.
Welcome.
Ladies and gentlemen, hands together for RVmagnetics. Thank you so much.
Thank you.
Wonderful. Already on our 9th finalist of 10 again. So 19, we're about to hear the 19th finalist of 20. Remember, Startup Booster competition, 20 of the best finalists. More than 150 different applications, more than 30 countries, and we've got the 20. We've had 18 already, about to hear the 19th right now. And this startup actually is from France, so we stay in France. Please welcome to the stage business engineer from Touch Sensity, Laetitia LAFFORGUE.
So good afternoon, everybody. I suppose everybody here has often take the plane once in their life. So what's happened when there is damage on the structure of the plane? It is, okay, sorry for that. So it is maintenance technician that will come and check the parts and just have a look at the naked eye of the parts, but it's not really reliable, and also doing a scheduled maintenance of it, which can take a lot of time and also a lot of money. So the best solution will be to make the materials speak. I am Laetitia LAFFORGUE, business engineer for Touch Sensity, and I will present you the Sensity Tech. So the technology allows to recover all the data from a pressure, a traction, a deformation as bending, and also internal damages in real time, and allowing to have access to all the data in a remote way. So it is an embedded system which is connected to the periphery of the material, sending a signal inside the material and then receive it. And after that, we use a processing system with our own algorithms of artificial intelligence, mathematical models to compare both signals, and then we can detect an interaction. We can also measure it, characterize it, and locate it as a 2D or 3D mapping, as you can see behind me on the slide. So the added values of the Sensity Tech compared with existing technology on the market is that it is a non-invasive system, so we respect the mechanical properties of the material. It can allow a real-time analysis, and also it can adapt to large surfaces and to any topologies, whether complex or simple. It can also allow to have access to all information as pressure, traction, deformation, and internal damage, and also allow to have a global vision, both a surface vision and a volume one, because it is your material that become our sensors. So the Sensity Tech allows to meet needs in structural health monitoring as predictive maintenance, which is a growing sector of 25% per year, and which represents 1.5 billion euros in 2024 in the transports and aeronautics and space markets. And we are able to do structural health monitoring on planes, rockets, boats, trains, cars, etc. So here is a proof of concept realized by Touch Sensity, which is a comparison between sound waves technology on the top and the Sensity Tech at the bottom, which consists on detecting 3 several impacts in real time. And so we can see, using the Sensity Tech, we can differentiate the impact area, the damages, and also the elastic deformation caused by these impacts. So in addition to all of this, the Sensity Tech also has a sustainable impact, as it can reduce the material consumption, the materials scrapping, and it can also extend the life parts. We only use recyclable hardware systems too. For industrials, it represents a benefits of 25% of reduction on labor costs on maintenance structure, which represents a reduction of 7.5 billion euros on the maintenance markets. Sensity is also a 2-year-old startup with 6 proof of concept realized, 2 patents filed, 1 fundraising of 1.5 million euros realized, a second one in preparation for 2022. It's also 1 partnership with Airbus Developments and several collaborations with Ariane Group, SNCF, Valeo, Naval Group. Our business model is on 3 several steps. The first one is a specification study, sale in collaboration with our customers. The second one is the embedded system sale, and the third one is launch of a software license. So it's also a 12-person company with 2 co-founders, a CTO and a CEO, 8 technical people on 3 different departments, so the materials and polymers department, an embedded system department, and also an artificial intelligence and software department with 1 project leader. At Sensity, we are all engineers, and some of us are doctors. And also all of our technical team members are experts in their fields. So Sensity, we are looking for collaborations with corporates in order to deploy the technology on the scale 1 part during exploitation in order to shift from a scheduled maintenance to a conditional one while having a sustainable impact. So it's only the beginning of Sensity history. So if you want to be a pioneer and take part of it, let's collaborate and meet this challenge together. Thank you.
There we are, right on time. Hands together for Touch Sensity. Let's go over to our jury members and hear what they feel about what they've just heard.
Okay, thank you very much for your presentation. I have a question. Can you give us some more information about the material technology you are using as a sensor? Is it a woven fabric? Is it a graphene layer or something else?
Yes, so thank you for your questions. It's only the materials of our customer that we are using, and we are not added anything in their materials. We use it as our sensors, and so the embedded system will be connected, directly connected to their materials, sending the signal inside their materials. So we can work on every materials. As we have only 2 years old for the moment, we are currently working on carbon composite part and fiberglass composite part also, but we can also take some plastic parts, aluminum, etc.
Any more questions from our jury members, perhaps?
Yes, in terms of maturity and certification for aerospace and defense, where do you stand? Are you already working on certification there, or on a...
We are just making some proof of concept with our customers in aeronautics and space fields. And so we are, via this different proof of concept, we are making some certifications, because we know there are a lot of certifications, mainly in the aeronautics and space fields. So yes, we are working in collaborations with our customers to take off step by step all the technological difficulties and also all the certifications that will be needed to take the Sensity Tech on a bigger project on this field.
And on the business model, how do you approach that? Is it a one-off sale, or is it more of a lifetime in all the cycle of the parts that you're making revenue? How do you do that?
Yes, so the business model is on the 3 different steps that I have shown. So the first one is working in collaboration with our customers on how we can integrate the Sensity Tech technology on their process. So yes, how integrate the technology on the process of our manufacturers, and after that, selling the embedded system part, and after that, also the algorithm part of the technology.
Maybe one last question from my side.
Yeah.
Is that a geometry-dependent technology? Do you need to train your system, or is it geometry-independent? I can give you whatever part, you lock the technology to it, and it's working.
Yes, so we are using both mathematical models or artificial intelligence to enter the use case of our customers, and it really depends on the use case. So if it is only just detection as an on-off detection of an impact, okay, we don't have to do it, but for
There
some
we
user
have
use
it.
case, yes.
There we have it. Ladies and gentlemen, hands together for Touch Sensity. Thank you, Laetitia.
Thank you for the questions. Thank you.
9 startups, 9 big ideas, difficult to choose a winner or difficult to choose who perhaps we should put forward as one of the 4 winners. We'll find out tomorrow 2:50 right here on this stage. We'll find out exactly who those 4 lucky deserved winners will actually be. We now go on to our 10th startup, from France over to Austria. We're going to hear from a startup known as Xarion Laser Acoustics. Please welcome to the stage application engineer, Mr. Tobias HOETZER.
You are manufacturing composites or using them in your products, and what you don't want is a structure like that. A structure with cracks, fracture, and delamination. This can make your structure fail. In the worst case, your airplane falls apart, humans are harmed, and you are at risk of going out of business. To prevent this, you need to inspect your structures. And this inspection problem is a $2.5 billion market. Now, we at Xarion are entering this market with a novel contact-free technology for ultrasonic testing. Now, ultrasonic testing is quite a standard thing to do, and you might ask why. Why is there a need for a new technology, and why go contact-free? And let me take you to the shop floor to show you how such inspection is currently done. The first thing you would find out is that all conventional ultrasound technologies are contact-based. That means you require a contact liquid between your probe and the structure. And this is bad because it's not sustainable and it's resource intensive, and you require a complex system for liquid waste management. But that's not the only issue. Contact probes are pressure and positioning sensitive, and this means it's hard to put them on a robot. And for a wide range of applications, manual testing is still the industry standard. Now you could solve this problem by going contact-free. And we at Xarion, we have expertise in ultrasound and in lasers, and we decided this is quite an interesting problem to work on. What we came up with is a contact-free probe, where we use lasers to generate and detect ultrasound. Our technology is very unique, and we have 27 patents issued. Now, for doing your inspection, you just require an air gap between the probe and the structure, and by scanning over surfaces, you can image the internal structures. And for example, we did this here for a honeycomb sandwich panel, and you nicely see how we image the internal honeycombs as well as a small-sized defect. We provide this as a turnkey solution with the required hardware and software for your inspection needs. And because we are contact-free and have a compact setup, you can easily put us on a robot. Additionally, we provide a good business case and can help you reduce inspection costs up to a factor of 10. And let me tell you about our current traction. We have projects with companies such as Porsche and Airbus, where we put our inspection probe on robots and bring it to the production lines. And our vision is to establish our contact-free method as a standard technology for composite inspection. And that's where you come in. And I invite you to please reach out to us and tell us about your inspection needs, because we'd love to collaborate and together with you bring our technology to your inspection lines. Finally, let me tell you about our team. We have 34 employees. We have background in all major engineering disciplines and core expertise in laser physics, acoustics, and material science. I'm Tobias. I'm an application engineer with Xarion, and I'm looking forward to get in touch with you and maybe already initiate our next projects together with you here at the JEC. Thanks.
Hands together for Xarion Laser Acoustics. Okay, let's hear from, for one last time, from our jury members about what they've just heard.
Hello, thank you for your presentation. One question from my side. Does your technology require a certain education from a technician to use it, or is it all in your equipment?
I'd say it maybe depends a bit on the application, but we are basically compatible with all standard NDT technologies or softwares, like for example with the Airbus NDT kit. And yeah, it maybe depends a bit on the specific problem. But like what I showed you, these simple kind of surface scans where you kind of image the internal structures, that's something where you don't really need a specific kind of education on our system, let's say. It's simply like with other conventional ultrasound methods.
Thank you.
In a honeycomb example, you showed a damage of, let's say, 1, 2, or 3 millimeter.
Mm-hmm.
How precise is this technology, and how small of defects can you actually detect?
Let's say, yeah, that's also a bit dependent on the kind of samples we inspect, on the, let's say, thickness and so on, and on the kind of generation lasers we can use. But kind of as the minimum defects we work with, and that's maybe less currently in the composite area, but we also work in semiconductor inspection, and we can resolve defects down to 10 micrometers, so pretty small sized actually. Yeah.
And is it also possible to do that at relatively high speed, because typically you need to look at quite a large surface area?
Yeah, so we have high-speed systems for kind of, this industrial use, where we have several of our detectors built in there, and we can, inspect, let's say, 48 square meters in 1 hour with a kind of, let's say, 2 millimeter pitch. Kind of, that's the kind of resolution that you would achieve, kind of, in these inspection images.
Okay, thank you.
Are you already industrially deployed somewhere at your clients, or still doing the proof of concepts?
Yes, I can know or tell that we are currently kind of at the, let's say, verge of going into production at Porsche for spot weld inspection. That's another area, but yeah, and we have other customers in the aerospace industry where this is also currently basically the systems are ordered, and yeah.
Excellent, thanks.
Ladies and gentlemen, hands together for Xarion Laser Acoustics. Wonderful, thanks so much, Tobias. Right, listen, you've heard them all now. We have had 10 this morning, 10 right now. We've been listening to, you know, some of we're jumping across the world, across the globe, across Europe, USA, other parts of the world as well. I heard some of these really great, innovative, cutting-edge ideas. All that it leaves us to do, not really us, but our jury members this evening, throughout the night, I'm sure, hours and hours, probably, hopefully they'll make it tomorrow morning still awake. They will come back to us tomorrow. Tomorrow, right here on this stage, we'll be announcing exactly who those winners are. We're looking for 3 winners, 1, 2, and 3, not first, second, and third, all equal 1, 2, 3 winners. together with one special prize for the best sustainable option as well. You probably heard as well, a lot of the questions from our jury members had a kind of sustainable perspective in their questions. That is why they were asked to find out, because we're going to find out exactly who that winner is tomorrow. Ladies and gentlemen, again, thank you so much for being with us. Wherever you are in the world, in your office, at work office, wherever you are, a big thanks as well, naturally, to our partners, our sponsors, and naturally our 5 jury members as well. Thank you so much for being with us. We'll leave it to you to decide who exactly the winners are. I know I couldn't choose, probably difficult for you as well. All that leaves me now to say is good evening, have a good night, whatever you do here in Paris, whatever you do wherever you are, and we'll do this all again tomorrow, JEC World 2022.